Hello student, I am Professor Devashish Bose, Head Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar, Madhya Pradesh. Today I am going to present a lecture of BSc 5th Sem on the unit Forensic Toxicology Part 4, which has been jointly prepared by myself and Ms. Priyanka Pahade, PhD scholar, a UGC JRF at Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Let's start our discussion while taking a look at what we are going to learn today. Module 1, an overview of extraction methods of poison. Module 2, extraction of volatile poison by different methods from viscera as well as other biological fluids, that is blood, urine, saliva, CSF, that is cerebrospinal fluid, etc. Module 3, extraction of non-volatile poison by different methods from viscera as well as other biological fluids, that is blood, urine, saliva, etc. And finally, when will be our conclusion. So let's start with module 1, that is extraction methods overview. So my dear student, today we are going to learn what is extraction and which type of procedure would generally be employed for that. In general, we can also say that it is a method of separation. There are many methods of extraction. The selection of method of extraction depends on different factors like nature of poison, matrix, and also quantity of sample available with us. The analytes of interest should be extracted from sample in minimum step to avoid loss during processing. The extracted material also required proper purification to avoid interference of matrix. The efficiency of extraction and purification determines the lower limit of detection, which is very important, precision, accuracy of the sample. The analyst plays a significant role in the selection of proper methodology on the basis of different parameters like case history, amount of samples, physical state of matrix, analytical requirements available in the toxicological laboratory. So first we start with the classical methods. Following methods could be classified as classical. Simple distillation. The technique of simple distillation involves heating a sample of liquid into a round bottom flask to convert it into vapors, which is then allowed to flow in another location called condenser, where it is cooled. Condensing is back into a liquid form. In basic distillation technique, there are many modifications which could take place. For example, steam distillation, fractional distillation, distillation under reduced pressure, sweep core distillation, etc. Now we talk about steam distillation. In this process, volatile substance which are present is heat sensitive. Matrix can be separated or isolated from blood, urine and viscera by the method of steam distillation. Here, steam is passed by tube from one container where steam is produced into the sample container and the aqueous distillate is collected by condensation. Acidic distillation process includes ethanol, methanol, phenol, hydrogenated hydrocarbons, cyanides, etc. On the other hand, basic distillation process includes basic drugs such as amphetamine, methadone and also aniline, pyridine, nicotine, etc. Now we talk about fractional distillation. This is a type of distillation in which different type of fractionating columns are used to enable separation of a mixture of volatile liquid. So when we take a mixture of two liquids having a temperature difference of 5 degrees centigrade, then we use this method. Suppose a mixture of ethanol and water may be separated by simple distillation, but if it is a methanol and ethanol, then we can use this type of distillation. Now we come to vacuum distillation. In this type of distillation method, separation of thermally labile volatile compounds, that is all those volatile substances which degenerate on heating, are carried out at low temperature without its decomposition. Now we look into sweep core distillation. It is a special type of distillation method in which preferential volatilization of organic compounds, especially pesticide, from oil, lipids or plant extract using a stream of inert gas, and after that isolation of volatile solid absorbents are taken place. Micro diffusion. This is a very easy and popular method that facilitate extraction of gaseous and volatile matters from biological matrix like blood, urine, stomach wash, and non-biological materials like water, drinks, tea, coffee, which contain trace amount of toxic anions. With this, we come to the modern methods of analysis. So, modern methods of analysis are sensitive, specific, reliable and accurate. They need much less time in comparison to that of classical methods. Following are the modern method of separations. Chromatography. Chromatography is a word or a term originated from Greek word chroma, which means color, and graphy, which means to write. It may be defined as it is a separation technique in which components of substance are separated into individual components according to their affinity with the mobile phase and stationary phase. This technique was first introduced by a Swedish chemist M. Tesvet in the year 1906 when he was separating plant extract. There are different types of chromatographic techniques. Some of them are mentioned here. Paper chromatography, thin layer chromatography, column chromatography. Paper chromatography. This is a separation technique in which active constituents are separated on cellulose paper, which acts as the stationary phase by using a mobile phase like water, methanol, benzene, ether, acetic acid or something else. This is the primitive method of chromatographic use for separation of organic dyes, pigments, inks, cations and anions. This is a method of partition chromatography. Thin layer chromatography. This is an adsorption chromatography. Generally, separation of mixture takes place on a thin layer of adsorbing material such as alumina, silica gel G or cellulose coated on an inert support material such as glass plate, plastic or alumina sheet. Quantitative separation is achieved by this method. This method is also used for the separation of dyes, inks, cation, anions and alkaloid. Now we come to column chromatography. This is an adsorption chromatographic technique. In this technique, a vertical glass tube or a stainless steel tube is filled with an adsorbing substance that acts as the stationary phase. The sample of interest is added onto the top of the column in the form of a solution in a suitable solvent or a mixture of solvents. The system of solvent is then added as a mobile phase, which is to be selected beforehand. Due to gravity and various components are separated. Fractions collected at various intervals will thus contain the different components separated at different intervals. In some cases, the net charge on the column material or sample molecule or both depend on the pH gives rise to greater analytical flexibility. Solid phase extraction or SPE. In older time, the extraction of poison was mainly carried out on solid material like activated charcoal and selective elution by solvents. Nowadays, a method is based on the use of small tubes or cartridges filled with around 100 to 500 mg of an appropriate absorbent, that is siliceous material, and bonded phase that are N-octadecyl, that is C18 or ODS, N-octyl C8, N-hexyl C6, ethyl C2, methyl C1, cyanopropyl nitrile CN, aminopropyl amino or APS etc. have been employed as absorbent with much greater efficiency of separation. Solid phase microextraction SPME. Solid phase microextraction is an extraction technique for organic compounds in aqueous sample in which analytes are absorbed directly from the sample onto the fused silica fiber that is coated with an appropriate stationary phase. When the fiber is inserted in the sample, the analyte portion from the sample matrix enter the stationary phase until equilibrium is attained. The fiber is then inserted into the injection port of a gas chromatography, where it is heated and the analytes are rapidly deabsorbed thermally into the capillary GC column for analysis. Hyphenated techniques HPLC-GC and SFC-GC. The hyphenated techniques, that is HPLC-GC, that is high performance liquid chromatography, gas chromatography, and SFC-GC, supercritical fluid extraction gas chromatography, allows complex samples to be pre-fractionated rapidly according to their molecular weight or chemical classification on a suitable HPLC pre-column or SFC, and appropriate fractions then separated by online capillary GC. The coupling of two techniques has been made by a bypass valve fitted with a sample loop of appropriate volume. Selected fractions are passed to the capillary column via a large retention gap which utilizes the process of concurrent solvent evaporation to retain the fraction in the retention gap, thus avoiding any preliminary contact with column. This is a very latest technique. With this, we come to the end of module 1 and we start the new module, that is module 2. Dealing with extraction method for non-volatile organic poison. Preparation of suitable extract. In biological matrix, especially tissue and protein having proteinous content interferes with the separation procedure. So, isolation and precipitation of this is required. After this process, filtration is used as a next step. Generally, this method are employed for extraction of non-volatile organic poisons from matrices. Now, we discuss these methods. Modified Stats Auto method. Here, 200 gram of minced tissue is taken, which is mixed with 400 ml of ethanol. A solution is acidified by addition of tartaric acid. It is heated for about 1 to 2 hours on a water bath. It is cooled and filtered. This process is repeated 2 to 3 times and all the extract are now mixed and filtrate. The filtrate is evaporated for ethanol to get the residue, and the residue is again extracted with 20 ml of acidylated alcohol in the same process. Extra alcohol is now decanted and a black brown residue is obtained. Acid digest method. Take a small amount of visceral tissue. To it, add a small amount of dilute HCl for precipitation of this slurry. To this slurry is added equal amount of distilled water. It is cooled and filtered. Filtrate. This method is useful for extraction of drugs like morphine, phenothiazines and barbiturate, but not useful for those drugs which are heat sensitive. Tungstate method. This method is modified form of Volvo method. It is useful for drugs that are acidic and neutral in nature. Here we take 50 gram of minced viscera. To it is added 50 ml of 25% sodium tungstate and 50 ml of distilled water. Then add 50 ml of 50% NaHSO4 plus 100 ml of water. Filter it, it is of dark brown color. Now we talk about ammonium sulphate method. Dear students, pay attention, this is a very important method. This method is known as modified Nichols method. It is useful for extraction of drugs from more protein content material, and it is useful for all types of drugs, that is acidic, basic and neutral drugs. Here we take 20 gram of minced viscera. To it is added 200 ml of distilled water It is made acidic by using HCl or acetic acid. To it, we add ammonium sulphate NH4SO4 till a saturation is attained. We filter it. So with this we finish module 2nd, and now we come to module 3, that is extraction method for non-volatile organic poison. Neutral and acidic distillate of volatile poison. Take 50 to 100 gram of sample, add distilled water to make a slurry, and to it add a little of tartaric acid for acidification. Collect distillate 4 to 5 times. This method is very important for extraction of alcohols, paraaldehydes, other aldehydes, acetone, carbolic acid and phenolic derivatives, carbon disulfide, thiamol, camphor, turpentine, nitroglycerine, benzene and other volatile acidic in nature. For cyanides and carbolic acid, the distillate is collected in 10 ml of 0.1 N sodium hydroxide solution. Basic distillation of volatile poison. Take sample remaining in flask after acid extraction. To it add NaOH for making alkaline. Distill is using distillation method. Collect distillate in 4 to 5 times. The distillate from the alkaline mixture may contain aniline, pyridine, nicotine, ammonia and other volatile. Most of the time forensic toxicologists receive such type of sample which is composed of lot of substances. So, in this condition it is quite difficult to identify an individual component or analyte from them. For this reason, extraction methods are used for separation and purification of mixture of compounds. This module is generally focused on the extraction of certain kinds of samples like volatile, non-volatile, solvent extraction methods and methods of extraction of insecticide and pesticide. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. Now, it's time for you all to do some self-study. This is Professor Devashish Bose signing off. If you want to learn more and enhance your knowledge, you may log on to our website for MCQ, quizzes, LORs at www.cec.nic.in. Till then, thank you and goodbye.